Welcome everybody. It is now the appointed time for the webinar, and it's interesting that the subject today on pipelines was a subject I'd been thinking about before Christmas and into the new year, because I had been talking to some clients and they were midstream clients, and some of the responses I was getting and some of the opinions caused me to look at pipelines a bit more closely, because there have been, as you will see, quite a few incidents. And it just so happens that we had the Colonial Pipeline issue as well that came up with the cybersecurity. So the subject, I think, is pretty relevant. And it's all about, are we really protecting the pipelines properly? So as usual, before we get into that, some of you are new to Exeter. Let me just explain a little bit about the company and give you a little bit of history. So again, the company Exeter was formed about 20 years ago, and Exeter actually stands for Excellence in Dependable Automation. And the reason the company was started was to try and help manufacturers understand what this new standard IEC 61508 was all about, and how to go about the process of certifying products for safety applications. Well, since then, the company's grown exponentially. We not only do product safety certification, we also do cybersecurity certification for products. We also do personnel certification. Some of you, I know, are CFSEs or CFSPs. Some are FSPs, some are CSPs. So the certification of personnel is also very important. Coupled with that, we've provide full life cycle services for the three main disciplines associated with overall process safety, which of course is functional safety, cybersecurity. And when we talk about cybersecurity, we're talking about the operational technology side of the firewall. We're talking about OT, industrial automation cybersecurity, and alarm management, and helping people with defining their alarm philosophies and helping with rationalization. So we can provide the full life cycle services, and to complement that, we also have a comprehensive suite of software tools to support the life cycles. So we have for functional safety, we have alarm management and cybersecurity. We are a global company. So since starting with 2 founders originally, we are now well over 120 people worldwide. We have offices over the globe. We are adding offices. We just added the Irish office in late 2020, despite the pandemic, and we are always considering new locations. The nice thing about the three disciplines, the functional safety, the alarm management, cybersecurity, it's pretty industry agnostic to a certain degree. So any process, any application where there's the prospect of having some safety issues, some functional safety issues, we can apply that. And of course, more recently, we're now dealing with the automotive industries and with robotics. Some of you probably seen these robots in the supermarkets, but they're also larger robots that work in warehouses that could cause significant injury and possible fatality if they were not properly in control and could run over a person. So we're doing a lot more in that arena too, as well as, of course, the traditional oil and gas, chemicals, steel, energy, etc. How we measure our success is that, well, we've moved away from being just owned by the initial 2 founders to being mostly employee owned now. We are the leader when it comes to product certification. We're also not just in terms of the safety side, but now in the cybersecurity side as well. We have more than 100 global experts. We've done more than 1,000 certification projects now and modeled well over 500,000 CIFs using the Excellencia tool. And here again, I'm sure some of you are probably familiar with the tool and actually use it. The other thing we do is publish a lot of reference materials. There are books that you can get through the website and now through Amazon as well. So you can download them from Amazon. Some of them are electronic, some of them you can order through Amazon. And these cover a wide range of applications. So we have functional safety, of course. We also provide books on cybersecurity, not just from the end user side, but also from the OEM side. And last year, my book on functional safety for managers, what managers needs to know, was published. We have the Safe Electrical Reliability Handbooks, which are still available, but we will be going probably fully electronic with those. These have all the failure rates. And this is what's built into the Excellencia tool to provide failure rate information for doing some of the CIF design and the SIL verification calculations. The other thing we have is free material, which you can access through the website. The Exeter.com website does have a lot of information that's very useful. We also provide the SAEL, the Safe Automation Equipment List, which basically will provide you with a list of certified devices, and you can find more or less most of the devices that you would come across in normal application. And you can see which manufacturer's devices they are. You can look at the certificate, and if we're allowed to publish it, you can look at the assessment report, which tells you how the failure rates for the devices were derived. These webinars that we do are also free of charge. They're recorded. They're available through the website. You can go to the resources tab. You can look at webinars. You can go into the archive webinars, and you can look under functional safety, certification, cybersecurity, alarm management. So lots of subjects, and these are all 45-minute to an hour max of YouTube videos, which are recordings from all the previous webinars. There are white papers there too, so you can look at the white papers. You can see that those white papers are downloadable. So again, I encourage people to utilize as much as possible the website and the free information that's there. A little bit about me. I've coming up to 45 years in industry now. My background is in electronic control system design, safety system design. I used to design ESD fire and gas and addressable fire systems, and then moved into the automation world and came back into safety about 9 years ago when I joined Exeter again. I have a varied role in Exeter. I look after the end user business. I have some global business development responsibilities, and I also teach our functional safety class, as well as I can teach the cybersecurity class. So that's the introduction. So let's get to the meat of all of this. And are you really protected when it comes to pipelines? And it's an interesting question, because I was quite surprised when I started looking at the incidents that occur with pipelines. And in looking at this, the statistics were that since about 2010, there were around 906 incidents through to 2019 that occurred in pipelines that were installed within the decade. So that's quite alarming, because that's almost 91 accidents or 91 incidents a year. And when compared to the same, when looking at the same number of incidents, compared it to the previous period before that, we found that that stretched for 40 years. So why the sudden change and increase in such a shorter time? So this was a sort of an interesting conundrum. And I suppose one could speculate on a number of reasons why that is. There could be time pressures to get the pipelines installed quickly and operating. It could be cost driven, so that there are shortcuts taken. Who knows? But the statistics are quite alarming. And when you look at the cause, it's interesting that the majority of the cases, it was equipment failure that caused this. About approximately 32% was due to equipment failure. So this is new equipment that's going in. So again, that's sort of puzzling. Why would we have equipment failures of that level? And again, you could speculate. You could say, well, equipment failures could be due to a number of things. It could be due to some configuration issues. It could be to the fact that we're using the wrong equipment. It could be that we're not considering the application properly. It could be a number of things. And then corrosion failure was the second most common reason. About 19% was due to corrosion. So here again, if these are relatively new pipes, then why would we be getting these sorts of problems? And interestingly, there is a program to replace some of the old cast iron pipes with plastic pipes, but that's an ongoing process, of course. And there's something like 2.8 million miles of pipeline in North America at the moment. So that's and some of it is considerably older than the last 10 years. So you'd expect there'd be problems with the older pipes, not with the newer ones. So this is another interesting area. And of course, what's been highlighted recently with Colonial is that cybersecurity should also be considered, because major pipeline infrastructure is a potential target, infrastructure in general. We know that from the utility side, they've had to tighten up since there have been a number of instances occurred probably 10 years or more ago now. And of course, wastewater and water treatment. There was the case last year and again earlier this year. So these are potential targets for would-be attackers. And this group called DarkSide claimed responsibility for the Colonial pipeline hack. So if you look at the statistics, it's quite alarming, really, with the different types of pipeline incidents: hazardous liquids, gas transmission and gas gathering lines, gas distribution. And you can see that something like 140 fatalities have occurred. And again, major incidences versus minor incidences. The major incidences is where we've obviously had the fatalities. And the damages were almost $5.4 billion. So it is quite staggering. Leakage is also an issue. Apparently, 0.35% of the volume of gas lost in transmission is mostly due to unintentional leakage. About a tenth of it is due to intentional, where it's vented or flared. So this means that 0.315% of the gas is released unintentionally. And it may seem like a very small number, but again, if you put it into perspective, if we just consider the Atlantic Coast Pipeline, which is scheduled to transmit about 1.5 billion cubic feet of natural gas per day, the expected leakage is around 4.7 million cubic feet per day. And over a year, of course, that's about 1.7 billion cubic feet. And putting it into perspective, that's enough gas to provide to all Pennsylvania residential consumers for about 13 days in August from just one pipeline. So leakage is another area that is obviously of concern. And of course, leakage can lead to the potential for explosions and major damage plus fatalities. Coming back to cybersecurity now. So what Colonial did, of course, was highlight the need to adopt cybersecurity as part of the overall site process safety. Now, it's interesting that there is an American Petroleum Institute standard to cover cybersecurity for SCADA systems. But again, does it go far enough? And one of the things that we'll look at is, could we be looking at a different approach? In fact, the Biden administration will now mandate cybersecurity regulations for the nation's leading pipeline companies. Up till now, it's mostly been following DOT or TSA requirements. And of course, the Department of Homeland Security now will require pipeline companies to report cyber instances to federal authorities. So it hasn't really been a mandatory thing to do that, but now they're going to push to have this done. And the White House has also launched a new strategy to tackle the growing threat to the critical infrastructure beyond what's been done before. Because critical infrastructure is an obvious target for external potential nation-state attacks. And for example, with the dark side, it's suspected that they are based in Russia, although it so far, to my knowledge anyway, it hasn't been proved that. But I mean, at all points, I think the federal government is convinced that's where it's coming from. So what are the consequences of this attack? Well, they mandated that within 30 days, and this was from, I believe, the end of April, they were to take steps to do an assessment as to how current practices line up against the current pipeline guidelines. And now companies have to identify gaps and establish a timeline for remedying these potential gaps. Up till now, it's been basically voluntary to do that, but now they're going to enforce it. And the TSA has committed to conducting 52 pipeline assessments in this fiscal year. Last report, they'd done about 23. So they are definitely digging in and looking at this. So what are the relevant standards that are applying? And mostly it's the American Petroleum Institute range of standards. API issued 2 standards in 2020. One was the recommended practice 1182, which was the construction, operation, and maintenance of large diameter rural gas gathering lines. And then the second edition of RP80, which is the definition of onshore gas gathering lines. So the purpose of these 2 were to enhance safety and operational efficiency to meet state and federal rules for ensuring safe operation of these pipelines. Typically, API 1160 is the overall standard to cover all pipeline integrity. So there's a range of standards that we will see that cover certain parts of it, but the overall is 1160. And then you have API 2350 that covers storage facilities and automated overflow protection systems. So all of this is great. But the thing about these API standards, yes, they talk about addressing risk, but they really work on a plan, do, check, act process. And this really comes down to culture and, of course, the leadership and management commitment to do this right. However, even though they talk about risk and it is a form of RAGAGAP, recognized and generally accepted good engineering practice, there are things that you could do or could be done better if we took a more risk-based approach. Yes, they address risk, but not to the levels of, for example, the way IEC 61511 does, or IEC 62443 for the functional safety and the cybersecurity, as well as the alarm management. So API 1130 looks at design and implementation of leak detection systems. API 1149 is the theoretical calculation of possible leak detection performance. 1164 is pipeline, addresses the pipeline SCADA security, and 1165 is testing verification of SCADA HMI displays and designs, and 1175 is the standard for the selection, operation, maintenance, and continuous improvement of leak detection systems. So all of these cover various aspects of the requirements. But it's interesting because, and as I said, one of the reasons why I started thinking about this and decided to do a webinar on this was from some of the conversations that I've been having. And most midstream operators will say, yes, we have protection, pressure protection, we do valve misalignment protection systems, we have leak detection systems, we have vibration detection systems for pumps and compressors, we have fire and gas detection, we have seal leak detection. So why do we need to think about a IEC 61511 and putting in safety instrumented systems? Well, the thing is that all of these are in the BPCS, and the basic process control system is not required to have the level of rigor applied to it that you would with a safety instrumented system. Yet, most of these systems are there to help provide safety. Pressure protection. If we have an overpressure situation, we need to know that our pressure protection is going to work reliably. So this is really where there's a false sense of security. The same with pipeline monitoring systems that are looking at the thickness. The Philadelphia energy service explosion in 2000, I think it was January 2020, they found that the point where the fracture occurred, which caused the massive leak and ultimate explosion, the pipe thickness was less than that of a credit card. And yet they had a pipeline monitoring system. The problem was that it didn't cover that particular section of pipe. So again, these things can sort of lull you into a false sense of security. And as you saw, the majority of incidents were equipment failure. So if we're getting a large amount of equipment failure, then maybe we should be looking at how we specify the equipment. And maybe we should take a more risk-based approach and utilize the approach defined in IE 61511 to take a life cycle approach rather than just the normal approach of plan, do, check, and act. So when it comes to looking at 1511, for example, and pipeline safety, so if we've got a high integrity pressure protection system that's employed, then typically this will be considered as part of or will be considered for a safety instrumented system requirement. So RAG-AGET techniques are required for risk reduction and mitigation. This means that we should be carrying out hazard and risk assessments and doing layer protection analysis to make sure that we've got sufficient protection, or if we haven't, that we define the additional protection. And if that additional protection requires a safety instrumented system with safety instrumented functions for given SIL targets, then that's what we should be doing. Because here again, and some of the counter arguments I've had when talking to some midstream companies is that, well, we don't need to put safety instrumented systems in. We don't have any. We don't need the cost. Yet, when you talk to them about, okay, how many shutdowns do you have? How many failures are you getting? And there are significant number of trips, failures due to equipment. So here again, the short-sightedness is that it's going to cost me a lot of money if I do this. But actually, if you do this, yes, all right, there might be an initial expense to do it, but over the longer term, you'll get the gains of having less trips or less failures, less problems, less likely to have incidents. Because, you know, dear old Trevor Kletz, he used to say, if you think safety is expensive, try an accident. And if they do have a major pipeline incident with an explosion and fatalities, then yes, it's going to be extremely expensive. So why not consider taking a risk-based approach around a life cycle to ensure, because again, these systems that get put in, how well are they maintained? Are they regularly tested? Do they do some form of proof testing or not? How often do they look at the useful life of the devices and either refurbish or replace them before they fail, rather than have a run to fail policy? All of these things can be considered. So safety instrumented systems with safety instrumented functions would give them that level of risk reduction. And of course, if we follow the life cycle, then we will make sure that we continue to achieve the level of performance that's desired. Same thing when it comes to the security. API 1164 covers the pipeline SCADA security, but we could apply IEC 62443, because again, following the life cycle approach, this is where we would do our risk assessments. We'd look at our critical infrastructure, the critical equipment. What happens if that equipment is compromised, or if it can be disabled as a result of a cyber incident? Then we can look and see, okay, what countermeasures do we currently have? What can we do to improve that? What security level requirements are there? So again, taking a risk-based approach, using a performance-based standard, means that we can utilize technology. We're not hamstrung by a prescriptive approach that says you have to do this, this, and this, and we can utilize the latest techniques. However, being a risk-based approach, we would have to have key performance indicators to be identified for tracking. That's not a big deal. We could do that. So this again would ensure that it's not a once and done. And the problem is a lot of people think that, okay, I've got the system in, I'm protected. Well, that might be fine from day one, but over time that's going to change, as we all know. So the life cycle approach means that we continually ensure, by tracking, monitoring the data, monitoring incidents, looking at failures and alarms, trips, etc., we can monitor that, we can improve it if we're finding we're getting a lot of these occurring. So this brings us back to the good old question of, why do companies have to manage risk? Well, the simple answer is there's a legal, a moral, and a financial obligation to do that. Now with pipelines, those can be running through the suburbs, through fairly densely populated areas. So there is definitely a moral obligation to make sure that we limit the risk posed by this. So of course, if you look at it in each one in its own merits, when it comes to moral, we should make it as safe as possible, irregardless of any cost. If it comes to regulations and the legal side of it, we have to comply with regulations as written, regardless of cost or actual level of risk. And here again, when I talk to some of these midstream companies, they say, well, we follow DOT and TSA requirements, so we don't need to worry about anything else. So again, this could be lulling them into a false sense of security, because meeting a standard doesn't necessarily meeting your objectives. And here again, from a financial point of view, of course, you want to build it as cheaply as possible and run it as cheaply as possible. So clearly, this would be in conflict with the other two, so we have to find a balance, and that's where the three overlap. So this is the important thing. So where's the current focus then right now? We know that most companies that are in the process industry, the typical refineries, etc., those would be looking at complying with the RAGAGAP requirements, because here again, a lot of the midstream guys say, well, we don't come under the OSHA PSM requirements. But yes, if you're storing and certain size facilities might actually come under that. But in general, yes, they don't necessarily need to meet the OSHA requirements. However, API is also RAGAGAP, and so you need to do the recognized and generally accepted good engineering practice. 1511, of course, is recognized as RAGAGAP. And with the changes that came in 2016, now we have to consider cybersecurity. And even there, in discussions with clients, we found that not everybody is embracing this. A lot of people still have this, well, we've never had a problem before, why should we worry about it now type approach. But it only takes one. If you get, because you haven't got sufficient protection and somehow somebody introduces accidentally malware, it doesn't have to be a nation state attack, it could just be a simple mistake made by an employee who's using an infected device, could be because they were doing some social media posting or whatever, downloading, and there was something in there, and inadvertently they've now provided the opportunity for exploitation, especially if it's ransomware, and then that can cost you millions, if depending on the size, of course, and what it is you're doing. So here again, adopting this approach, taking this life cycle approach, taking a performance-based approach will give you that opportunity to define what you need to do based upon how much risk you're willing to accept. And as long as that risk is within societal norms of what is expected, that's fine. Same with alarm management. Alarm management is not always considered even when implementing 1511, but it is required in API 1165. So having properly rationalized alarms so that your operators are trained and understand and know what to do and will see the alarms coming in their priority order and will have time to deal with them, then that in itself, because there have been incidents, as we shall see in a moment, with alarms or the way that the alarms were treated causing a problem. So we need to consider all three life cycles if we're going to properly contain and mitigate the risk. So if we look at this from an operating landscape point of view, of course, what surrounds all of this is culture. The culture, meaning that what is the culture of the company? What is the management culture? Is it to make sure we can do as much as we can to protect and safeguard not just our employees, the public at large, and obviously protect our shareholders? So this requires that we have properly trained people who are competent to be able to do the work. It also means that we need to be careful about the equipment we use to make sure that we have reliable equipment, and it also can be robust against any potential cybersecurity threats. So if we look at these together, the consequences of inaction or deviation, if the operator cannot see the wood for the trees because he's getting flooded with all this information and he can't pick out the key alarms he has to deal with, that can use up vital minutes and could lead to a very poor decision, or worse still, could lead to the ultimate consequence, which is an explosion. Then there's the consequences of failure on demand. So here again, if the equipment, if we have protection systems in place, but they're not designed to provide the level of risk reduction we need, the performance we need, if they fail on demand, that's another problem. And of course, consequences of compromise, whereby both a safety instrument system and a basic process control system or a SCADA system is compromised and disabled through a cyber malware incident, then of course we've got another potential major problem. There are interdependencies between these, and these are indicated by the little house symbols, if you like, between the circles. So we have the standards themselves, 1508 and 62443 for the equipment. The certification side would be CFSE or CACE for safety and cyber and alarm management. And then we would have the 62682 for the alarm side, also covered under ISA 182. You have 1511 for the consequences of failure on demand for the safety instrumented system. 62443 would cover the consequences of compromise from the cybersecurity. And of course, these interceding points is where we can use policies and procedures and tools to help us. So taking a systematic approach towards it, using a performance-based life cycle approach, will yield benefits in the longer term. Yes, short term, it may cost a bit more because we have to we have to spend more on the equipment and on training and on these other things, but in the longer term, it will save us money. So from a practical point of view, successful implementation obviously requires a thoughtful approach. You've got to think of it carefully. Just complying with a standard doesn't necessarily mean we're going to reach a goal. So we need to understand the structure, tailor the processes to meet the needs of the sites and the capabilities required. So this requires us to understand what is the competency of the people we have, what equipment do we have in place, what do we need to have in place, and what are the metrics that we have to have in place to be able to measure. Some of you have been on my webinars before and heard me teach, and I'm always going on about this point. You've got to have the right culture, otherwise it's going to be very difficult for the people that are trying to implement this, because it'll be like pushing on a rope with management pushing back every time you need to spend money and do things to ensure that we're meeting the requirements. Having an open and learning culture is very important, because the whole point of this is that we want to learn from the operational side of things. So if we are getting a large number of incidents or equipment failures, we need to understand why. We need to take steps to fix that. If we see that operational processes are being shortcut or procedures are not being followed properly, then people should be able to speak up and say that without fear of any retribution, which can happen. So doing things right and doing the right thing should be the mantra. So we make sure that the O&M people are properly trained, follow procedures, we're doing the mechanical integrity, we do inspections, we do the testing correctly, we use metrics to help us with this, and we document everything. Whether we use software tools to help with the documentation or not, we need to do that. If it's done right, as I've said, it will save time and money. And it is a long-term investment with some short-term gains that can be got. So if you look at all three life cycles, as I've said, you've got the functional safety side, the cybersecurity, and the alarm management. They all have the same three phases, which is that you need to do some form of assessment to look at the risk, identify what needs to be done, design your mitigation, and then put it into operation and maintain it. And of course, this is governed by having the right policies, procedures in place and a plan to deal with it. I mentioned earlier that we'd look at an incident. Here's an incident for around the Columbia gas pipeline rupture, and this is specifically around alarms, because what happened here was that again, because of the fact that corrosion had reduced the thickness to 0.078 inches, it caused the rupture and the explosion. There was a delay in turning off the gas, so the gas was feeding this for almost an hour. And of course, the impact on this was homes that were lost to fire. There was damage to a highway. The pipeline repairs were about 2.9 million. Updating the inline inspection system cost around 5.5 million. And of course, the loss of the gas itself was about 285,000. So this was a significant incident. There was no automatic shutoff valves or remote control valves. They had not been installed. The alarm screen itself had been divided into three sections for alarms, alerts, and communication outages. And there were numerous pressure deviations alerts being generated. The delta pressure was about plus or minus 10 psig. And the problem was that the controller didn't recognize what it indicated. He couldn't figure it out. So why didn't he take the right action? Well, first and foremost, there was incorrect diagnosis. He didn't realize that the rupture had taken place until after being called by another controller. There was no documentation or training on the expected response to alerts. There was a lack of situation awareness as well. The alerts weren't configured to provide specific meaning, and of course, timescale for response. The alert display showed the value of the change, the delta P, but didn't indicate whether it was increasing or decreasing, nor the actual value of the pressure. So what is the difference then in this cognitive load on the operator? So to reduce the frequency of nuisance alarms, what they did was they defined the SCADA system with alarms and alerts. and only the alarms were counted in the KPIs. So for example, 2 per hour, if they're outside of safety-related parameters, but the alerts were 95 per hour outside of operator-defined controlling parameters. So again, per the 18.2 standard, you should have no more than 6 to 12 alarms per hour. This is considered manageable. In other words, no more than really one or two, well, one alarm every 10 minutes, for example. So these alarms were seemingly recategorized as alerts simply to meet performance requirements. So there was a playing, if you like, with how the alarms were defined, which caused the problems because they weren't properly defined, and because they were nuisance alarms, they were just recategorized as alerts without really looking at why are we getting that. So clearly, we need to be able to measure performance. If we're going to take this approach, which to me seems to be a sensible approach to take, by implementing performance-based standards that are not prescriptive, defining what the risk is, assessing that risk, implementing the correct mitigation steps to reduce that risk to tolerable levels. So we need to be able to measure the performance of these when applied to either the safety instrument system, the BPCS, and any SCADA applications. So we've got to have these metrics in place, and we could use leading and lagging indicators, of course, but there are other metrics that can be used. The point is we should be measuring. So this means we should be following this life cycle approach. In my estimation, I believe that if we do this, we could help reduce pipeline incidents by taking a more performance-based, risk-based, holistic approach to understand what the hazardous risks are and the associated consequences, and then what we can do to mitigate that in a cost-effective manner that meets the company's requirements and also provides a safe operating environment. We know cybersecurity is a real threat to infrastructure. It can't be ignored, and of course now it's not going to be ignored. It's going to be pushed from the federal point of view. So cybersecurity coupled with proper alarm management and functional safety processes, procedures will definitely help us improve our performance. And if we have the learning environment where we can utilize the results from the metrics, we can help improve how we manage risk and maintain it throughout the lifetime of the systems. Pipeline equipment failures, therefore, can be managed and reduced by following safety life cycle as defined within 1511. So again, where we need to identify safety critical applications, then we should be considering the use of a safety instrumented system and the IEC 61511 approach. And I know a lot of the midstream guys say, well, that's just process and that doesn't apply to us, but it could be applied, and it could be applied intelligently, and it could reap benefits if it's done properly. Because proper mechanical inspection, maintenance, and monitoring systems can help with reducing the impact of leaks. Mechanical inspection is, visual inspections, looking for signs of corrosion. Yes, you can have the pipeline monitoring systems, but again, those should be maintained, and we should make sure that we're applying it correctly. Understanding these interdependencies between the three helps us make sure, or will help us to ensure, overall pipeline safety and risks are managed and maintained within those acceptable levels. And nurturing the right culture is very, very important. It's vital to the successful implementation of any of this. Having right metrics, as we've said, to be able to measure and assess performance is also very important. And how often we choose to do that is important too. If we're having quite a few incidents, then we should be doing this more often than if we're not. And then making sure that our employees are properly assessed, that we have a competency assessment program and a training program in place to keep them up to speed. We should be recording all the maintenance activities accurately and faithfully, and we can then use this information during the hazard and risk assessment revalidation. Because clearly statistics are showing that there is not enough being done to prevent pipeline incidents. Even though there are all these API standards, it's still not enough. Okay, so that's the end. I see that there are some questions popping up. Let me see what. All right, so do you have any experience with pipelines where flowing blend of natural gas and hydrogen? If yes, which additional requirements should be taken? Well, as I've said throughout, I think, again, if you're going to do this properly, then it should be following a performance-based standard. So you should do a risk analysis. You should look at what are the risks associated with this, and again, rank the consequences and the likelihoods and look at the worst case, the most severe consequence and likelihoods, and address those first. So I would suggest that's the approach that should be taken, because as I said, the API does talk about managing risk, but really and truthfully, if you want to do this properly, my suggestion would be to follow the 1511 standard to do this, because it's a methodical life cycle based approach where we properly assess the hazards and the risks associated with that, the consequences, the current layers of protection we have in place, and what we need to do further to address that to mitigate the risk to within acceptable levels. So of course, this means that the company has to have some form of defined overall risk tolerance. Any other questions? Okay. Have you come across CI2 and H2 pipeline incidents? Me personally, no, but again, if you want to, you can go to the PHMSA website. This is the pipeline and hazardous materials safety. You can have a look at that website. The PHMSA website is a good source. They've done a very good job of listing particular incidents against particular applications. And they don't just look at the pipelines, they look at rail, they look at air, they look at road, they're looking at all of these potential incidents. So I would point you there to go and have a look. Any other questions? Okay, well, again, if you do have questions that you think of afterwards, feel free to drop us a line. You've got my email address. Again, follow us on the usual social media. We're always looking to get feedback. And you can email me at sgandy@exeter.com if you have any further questions that you think about. It looks like somebody does. Can you share some information on what happened to the Colonial Pipeline? What type of attacks? Well, it was a ransomware attack. There aren't at least I've not seen too many further details on that. I'm sure that eventually it will come out. And this is part of the problem, is when companies get compromised, they don't necessarily want to share that. They don't necessarily want to wash their dirty laundry in public. And to a certain degree, I don't blame them. The thing is, unless we know how these incidents occur when it comes to cybersecurity and how people are compromised, how does ransomware get in there? How did they exploit a weakness? And one of the things that we talk about when we do the cybersecurity training is to highlight the fact that of the incidents that occur, most of the time, about 80% of the time, it's because of what we call the stumbling, fumbling, and bumbling. if you like, it's the basic awareness, cyber hygiene, because people don't think about certain things. You know, social media, you've only got to go anywhere these days, and people are on their phones. They're texting, they're doing social media, they're posting, whatever they're doing. So there's an awful lot that goes on through social media, and a lot of these hacks can come through social media. They can embed ransomware, or they can embed malware. They can target certain companies that way. And if the employees are not up to speed on this, the same thing with phishing emails. You know, I had a couple myself this week where it looked like Microsoft was sending me a note, or through my Office 365, it was sending me a note to say, oh, I needed to update my password and I needed to click this link to do that. And I thought, well, why would I need to do that? And so when you look carefully at the email address, you can see it's not coming from where you expect it to come. So of course, delete it immediately. Don't click on any links, because otherwise, this is how people inadvertently get hacked. And of course, from a company point of view, if you don't have the proper procedures or the training in place to alert employees about things they shouldn't do, for example, if they need to change or to charge their phone, they plug it into their laptop to charge it. That's not a good move either, because again, if there's any malware that's been managed to get in the phone through social media, for example, then it can easily be transferred into the laptop or the machine that you're using. And once it's in there, it could start to infiltrate, depending upon how good your firewalls are and everything else. So a lot of the times it's through awareness, making sure employees are properly trained and aware of the do's and the don'ts. If you do that, you can probably protect yourself quite well initially. And then, of course, you need to look at the infrastructure of the network. And when I talk about the network, I'm talking about the industrial controls network, or the process control network, as it's sometimes called, the PCN. Okay, I think that's it. I don't see any more questions. Well, I thank you all for attending, and I hope you will attend future presentations. With that, I shall bid you farewell and enjoy the rest of your day or evening or wherever you are in the world. Thanks.